Hello everyone, I'm Kshitij Pandey from Kshitij College of Engineering. I'm pursuing BTech in Computer Engineering, currently in third year, Sem 5, and this is my honors IA2, which is title is An Overview of Data Analytics in Smart Agriculture. It is submitted by a group of students, Bhakti Lahane, Kshitij Pandey, which is me, Rithi Patil, Smith Patil, and Toyash Patil. So the abstract. Smart agriculture uses various modern technologies and devices such as to fetch data. It uses sensors, IoT devices, and UAVs for further driving the decision making. Analyzing this data can help the farmers to get a meaningful insight on crop growth, soil health, weather patterns, enabling farmers to optimize planting and set a harvesting schedule. So smart agriculture is basically revolutionizing modern farming by integrating cutting-edge technologies and making use of devices such as sensors, IoT devices, and big data analytics. The benefits or advantages of smart agriculture are better crop health monitoring, lesser impact on environment, ensure food security in case of climate change, and reduce operating expenses while increasing yields. So the methodology that is followed is data collection. That is, we collect the data from sensors or whatever are being placed at key locations. Diagnostics, we analyze the collected data, identify the critical issues, make an inferences from them. Decision making, based on the analysis in the diagnostics phase, we make a decision as to what could be done or what should be done. And in the action is basically the actual implementation of the decision making. Okay, so there are various analysis types that we have followed. The first one is predictive analysis. So farmers can use this predictive analysis to determine the forecast the crop yields, weather patterns, and pest manifestations. So basically, this would help the farmers to know in which month in future there could be more yields and in which weather. The model that has been used is profit model, which is a time series model. Dataset, we have a CSV dataset, which has various columns, state name, district name, year, crop area, production, etc. So first the steps are data aggregation, then exploratory analysis, forecasting, various Python libraries that are used such as Pandas, Matplotlib, Seaborn, and Prophet. So we are basically making a future prediction for the next 10 years based on the historical data which is actually present. So this is a graph of crop production versus yearly crop production in India. We can see before 1998 it was quite less, but then after 2010 it has seen a steady increase and some fluctuation in it. So this data is basically till 2014. Now you're making a prediction for next 10 years, 2015 to 2025. This is an output of the profit model in which the blue line is the predicted one, whereas the black is the output and the blue shady area is the probable region. Okay, so we have basically gotten the data of next 5 years from 2015 to 2025. It is the graph trend over years. So this is from 1996 to 2024 again, which has seen a steady increase. This is yearly or basically monthly, Jan, Feb, March. Now we are talking about data analytics in livestock. So livestock farmers can leverage data analytics to monitor the animal behavior, animal pattern, and track their feed or food consumption and growth rates. Basically, this information allows farmers to learn about their breeding practices, veterinary care, ultimately enhancing the animal welfare. So in this, 5 charts have been generated, and we'll see each of these 5 charts briefly. First, I'll show you the execution of these 5 charts. So this is the Python code. This is our CSV live CSV dataset. Let us run the code. So now we have got a graph of food consumption versus the weight. So these are the various breeds of animals. Okay, this is their weight and this is their food consumption. So the green one, which is Jersey, it has a lesser weight in comparison. So it has the least food consumption. Whereas we can say that Hereford, with the maximum weight of 700 kgs, has a very high consumption, food consumption, daily food consumption above 34. The next graph that we have got is distribution of health scores. So this basically tells us about the health score of each breed of the animal in the livestock. This is the growth rate versus age. Whatever animals are present, what is their growth rate and in what age? So at the age of 2 years, it had a growth rate of 11, whereas as it grew 3 years, it had a high growth rate, whereas it started declining as the year increased. Maternity visits versus health score. So uh, you can see that again, Agnes had very less maternity visits and a very high health score, whereas Groti had a very high maternity visits as well as a very high health score. So by this, the farmers can come to know which animals have what health score and how many maternity visits have been, uh, how much maternity visits do they require. This is the graph of daily activity versus behavior score. Okay, so basically, we can see that the daily activity in hours of Guernsey or Husky is 6.0 and its behavior score is 7. The one which are more active are tend to naturally be more behavioral. For example, as we can see, Kryptons has got daily activity R of 7 and it has got a behavior score of 9. So this is the implementation of my part of livestock analysis. We have used pandas library, matplotlib library, and Seaborn. Let us move on to the further part of the PPT. We have seen each of these graphs: food consumption versus weight, distribution of health scores, growth rate, maternity visits versus health score, and daily activity versus behavior. So the next that we have is precision farming. Precision farming basically involves using data analytics to analyze crop production by tailoring farming practices. Okay, it analyzes the soil and moisture data. The dataset is in CSV. It has various columns. It has timestamp, moisture flow sensor data, irrigation, and moisture. So data pre-processing has been done, data visualization, exploratory analysis, optimization, simulation, and various Python libraries that as Pandas, Matplotlib, and Seaborn and Sklearn have been used. So as we can see that this graph basically tells us about correlation between moisture sensors, what is the moisture content and how much the moisture content is there. The darker the shade, the more moisture content is present. This tells us about the moisture levels over time, how much the moisture level has increased over time. And the irrigation over time is constant, there is no increase. Actual versus optimal irrigation in precision farming. So this is the average moisture level, and this is the optimal irrigation, whereas this is the actual irrigation. So supply chain management is the next topic. Supply chain management data analytics can be used to optimize supply chain in agriculture to have an analysis on seed production. Okay, it helps in transportation logistics, cost reduction, quality control, and in demand forecasting. So the agricultural raw materials practices dataset. It has the following uh, month, price, percentage change. Okay. So now we have a graph of soft sandwood price over time. So we have the price of a crop. The farmers can use this analysis to understand what is the price How much has the price of a crop increased or decreased over time? How much is the change that we can see percentage of change in the price of the cotton or soft canwood or whatever it is? Can be seen that the price in 1992 was pretty low, but then between 2004 and 2008, probably 2007, the price has seen a steady increase, whereas in 2016, the price has seen steady decrease. Plotting sandwood price percentage over time. Again, soft sandwood price over time has been plotted, and 3 month moving average has also been plotted. Next is data analytics on weather forecasting. So basically, as we have told you, data analytics is very useful in forecasting the weather, which weather is best suited for uh, yield or for better production, and which weather is harmful or disastrous for the food for the yield. So that farmers will not produce in and do farming in that weather. So we have again used descriptive analysis, unique value analysis, and various other processes. This is a graph which says about soil moisture, temperature, frost, soil temperature, precipitation, degree days, relative humidity, wind speed, and wind direction. Okay, so we have a prediction of the rainfall over here over year from 1999 to 2003. You can see that in 1997, this basically tells us the red bar is what would have been the forecast, whereas the blue bar is what actually happened. It's basically a comparison between the historic and the predicted value. We can see that the blue is historic, which already happened, whereas the red is the predictive one. Okay, so this is again the temperature analysis, temperature, dew point, humidity, wind speed, and the conditions. So conditions basically tell the farmer that the cloud is going to be mainly clear, atmosphere is going to be mostly cloudy or it is clear. Conclusion. Data analytics. Basically what we can conclude is data analytics help us in increasing the production, yield, and it allows the farmer to have an analysis on what time is the best for him to do farming and get most profitable yields, whereas which time is prone to disasters, heavy rainfall, and it is not prone. It also tells the farmers of livestock, the health of its animals or its breeds, and how often do they have to visit the veterinary store. These are our references. Thank you so much.